Hello everyone, this is Mr. McMillan, and I'm here today with the instructional video on the interior and exterior angle measures of polygons. So the first bit that we're going to talk about is the interior angle measures of polygons. And we do have some experience with interior and exterior angles. We talked about those when we talked about parallel lines and transversals. So an interior angle, if you might remember, is an angle that is located inside of a shape or figure. Okay, so interior, just like the interior of your room is the inside of it, it's the same thing with the interior angle. All polygons have the same number of interior angles as they do sides. Okay, so they have the same number of interior angles as they do sides if they're convex especially, okay? So the ones we're gonna worry about are the ones that are convex, okay? The interior angle measures of polygons as far as irregular ones go and concave ones go, you know, those run into some issues with the dents and the cave-in points. So we're exclusively focusing on convex, okay? So should technically say convex there, but you know. So let's look at the following diagram of a triangle. In this diagram, we see that we have three angles labeled here. And we know we have three angles. We have the 63-degree angle here, the 27-degree angle here, and then a box in the corner. And of course, that box represents our right angle there, which measures 90 degrees. So what are the measures of the interior angles? Well, as we said, we have 27 degrees, 63 degrees, and 90 degrees. All right. Now here, we want to know what the sum of the interior angles is. So of course the sum meaning we're going to add all of the interior angles up. So if we take 27 degrees, and add 63 degrees, and then add 90 degrees, you should see that you get 180 degrees for your sum. And of course, when we talked about triangles, we talked about triangles having interior angle sums of 180 degrees every single time. That was what made one property of the triangles when we learned about them, right? They always added to 180 degrees for the sum. So, a triangle is not the only polygon, right? You have a bunch of other polygons. You got quadrilaterals, pentagons, hexagons, heptagons, octagons, so on and so forth, right? Well, let's see how we can use that information to determine the interior angle sums of the other shapes. And the way we're going to do that is we're going to be looking at the diagonals. So let's look at, we're going to do four shapes here. So the quadrilateral, what we're going to do is we're going to start at a point and we're going to draw as many diagonals as we can only from that point, okay? So I'm going to start from this left point here, bottom left. And if I start from this point, the only diagonal that I can draw is the one that goes to this, this corner, which is your top right corner there. And what do you notice about what is formed when we draw that diagonal in? Well, you should see that there are two different triangles here. Okay, there are two triangles here, and those two triangles are important because we know that we have four sides and we have two triangles formed here. And we also know that the sum of the interior angles of a triangle is 180 degrees. So both of those have interior angle sums that equal 180 degrees. So if I want to find the sum of the quadrilaterals interior angles, We can do that by taking the sum of the two triangles that we have. So the sum for the quadrilateral would be 180 plus 180. You could also say that that was 180 times 2 because you have two 180s. And when you do that, you get 360 degrees. So the sum of the quadrilateral interior angles is 360. Now, let's repeat that process for the pentagon. We're going to start from a diagonal or from a point. It doesn't matter which point. And we're going to draw as many diagonals as we can. Regardless of the point you start at, it's always going to end up with the same number of diagonals. So I'm going to start from this leftmost point here. And remember, a diagonal doesn't refer to how it looks, whether it looks like a diagonal line or a straight line. All a diagonal does is connect two non-consecutive vertices. So for instance, here, I can extend this line here to that point. That's a diagonal. But I can also do one more here. And I can do it to the bottom right point here. And that's the only ones I can do from that point. So how many triangles have we split this into? Well, as we can see, we have one triangle there, a second triangle there, and then a third. So a pentagon has 5 sides. And it formed 3 triangles when we drew out our diagonals. So since we have 3 triangles, we have 3 180-degree interior sums. So we take the sum, and it's equal to 180 plus 180 plus 180, which is the same thing as 180 times 3, and you get 540 for the sum. Have you started to notice a pattern? Well, if you have, then that's great. We're going to go on and draw diagonals for one more shape, which is the hexagon. And then we'll talk about what we're going to do with the heptagon. So a hexagon has 6 sides. And we're going to draw our diagonals again. Again, it doesn't matter which one you start at. So I'm going to start at the leftmost. And we can draw one here, here, and here. That's a very bad diagonal, but it'll work. So how many triangles does it form? Well, as we can see here, we have 1, 2, 3, 4 triangles, and they each have 180 degrees for their interior measures. So we have 4 triangles. So our sum for a hexagon would be 180 plus 180 plus 180 plus 180, which is 180 times 4, which gives you 720 degrees. So, what is the pattern? Well, let's look at a heptagon. Now, a heptagon has 7 sides. So, from the last few things that we've done, could you figure out how many triangles that a heptagon would have in it if we drew our diagonals the same way? Well, if you look based on our sides to triangles, we have 4 sides to 2 triangles. So here we have 2 more sides than we do triangles. All right, does the same thing hold true for the pentagons? Yes, we have 2 more sides than we do triangles. Same thing for the hexagons. So for the heptagon, you would say that our triangles would have to be 2 less than the number of sides we have, which in this case would be 5. And we're going to do that just to verify. So we've got a point here, diagonal, 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 and diagonal. Does that form 5 triangles? And the answer is yes, that forms 5 triangles. Now, if we want to find the sum of the heptagon, we could just add 185 times, or we could do what we've been doing and do 180 times the number of triangles, which is 5. And when you do that, you end up getting 900 degrees for your sum for a heptagon. So from this, we should be able to note a pattern. We've already noted that the number of triangles is equal to the sides minus 2. And we also know that the sum is equal to 180 times the number of triangles. So if we write that down, the sum of the interiors, the sum of the interior angles is equal to the number of triangles times 180 degrees. Now we said that to determine the number of triangles, you have to take the number of sides and subtract 2. So that's what we're going to do. So the number of triangles, we're going to say that the number of sides is equal to n, and then we're going to subtract 2 because that's how we figure out our triangles, and then times 180. So our formula is the sum is equal to the n minus 2 times 180, where n is the number of sides. And specifically, n has to be greater than or equal to 3. All right. Now, that's not the only thing we can do. We can also determine the single interior angle of a regular polygon. Now, since a polygon is, if it's regular, that means that it has all angles being congruent. All angles are congruent. So every single angle is the same. So if you have a pentagon that's regular, all 5 of the angles have to be the same. So since they share that sum for the interior, you have to evenly divide it by the number of angles you would have. And the number of angles you would have is determined by the number of sides. So to determine one interior angle of a regular polygon, your interior angle is equal to the sum of the interior divided by the number of sides. So formally stated, you find the sum, which is n minus 2 times 180, and then you divide it by the number of sides, which is just n. And of course, n still has to be greater than or equal to 3. And that works for any polygon that's regular. Okay? So this is to find your sum. This is to find one of the interior angles. All right, so let's look at the exterior angles now before we jump into some problems or some examples. So your exterior angle measures of polygons. Now, unlike interior angles, which are inside, exterior angles are outside of the shape. And specifically, an exterior angle is the angle between any side of a shape and a line that's extended from the next side. So let's look at the diagram of the triangle that we did above. Now, it's on a different page, but you get the idea. The triangle with extended sides. So this is the same triangle we had. So we have the same interior angle measures. Now, we want to determine the measures of those 3 exterior angles. And if we look here, we notice that they come in pairs, right? So they're with the interior angles. And if we look at x and 63, we see that x and 63 both lie on this line. And if you remember, a line has an angle measure of 180. So x and 63 both lie on this line, so they have to combine to form a 180-degree angle. So these two are a linear pair. And of course, linear pairs are always supplementary, which means they sum to 180 degrees. So x plus 63 must equal 180 degrees. So to find x, we take 180 and subtract 63. and we get 117. So we have 117 degrees for our first one. The next one here, we're going to figure out y. Now, if you look at y and 27, they lie on the same line. So in order to find y, you have to take 180 minus 27, which is 153. And then finally, z, you have it and the 90-degree angle are lying on the same line. So z has to equal 180 minus 90, which is 90. Now, it wants to know what the sum of the exterior angles is. And when we add those together, we add x, y, and z together, we get 117 plus 153 plus 90. And if you type that in the calculator, figure it out, you end up with 360 degrees for the sum of the exterior angles. So, as we found above, we can conclude that interior angles and exterior angles form a linear pair. This means they are supplementary, which means they sum to 180 degrees. Okay? So interior angles and exterior angles for convex polygons always form a linear pair. So let's look at a couple more shapes to see how the exterior angles compare. Okay, so we're going to be looking at the sum of the exterior angles. So in this first quadrilateral, our exterior angles are out here next to the interior angles. So they're supplementary, so they have to add up to 180 degrees. So you take 180 and subtract 81, and when you do that, you get 99 here. Here you'll get 180 minus 99, which is 81. And then these just repeat. So this would be 99, and this would be 81. Now, it's not always going to be like that. That just happened to be how this one was drawn. So we're going to find the sum of the exteriors. And when we do that, we get 81 plus 99 plus 81 plus 99. And when you add all those together, you end up getting the sum of the exterior angles is 360. So the triangle and the quadrilateral had the exact same sum of the exterior angles. Interesting. Let's see if that matches up with the hexagon. So the hexagon, we have 6 exterior angles we need to do. And if we fill these in, this exterior angle here is 180 minus 90, which is 90. 180 minus 136 gives us 44. 180 minus 145 gives us 35. 180 minus 102 gives us 78. 180 minus 97 gives us 83. And 180 minus 150 gives us 30. So those are our exterior angles. Now we're going to find our sum. So we take 30 plus 90 plus 44 plus 35 plus 78 plus 83. And if you type all that into the calculator, you'll find that your sum of your exterior angles is 360 degrees. So it seems like no matter what type of shape we deal with, the sum of the exterior angles is always 360 degrees. And this is true. The sum of the exterior angles for any polygon that's convex will always be 360. It doesn't matter whether you have a pentagon, hexagon, heptagon, octagon, so on and so forth. It does not matter. So down here, your sum of the exterior angles of a polygon, it's the easiest formula in the world. It's always 360 degrees. So the sum of the exterior angles is always 360 degrees. Next up, a single exterior angle of a regular polygon. So just like the interior angles, we can figure out one exterior angle of a regular polygon. They're all the same, and the number is dictated by the number of sides. So one exterior angle is equal to the sum divided by the number of sides. Well, the sum of the exterior angles is always 360. And the number of sides is always n. So 360 divided by n will give you one exterior angle. It is of note that that's the regular polygon. If you have an irregular polygon, you need to make sure you use something like this. All right. All right, so we're going to go over some examples. The other examples are on this page for you to practice on your own. I will have the key to the whole thing posted after I post the video, so you can look at that and see how you did with that. So find the interior angle sum for each polygon. So this is for numbers 1 through 8. It wants us to round your answer to the nearest tenth if necessary, which should not be necessary for these. So let's look at number 1. We want to find the interior angle sum. So a good thing to get in the habit of is when you're learning these, make sure you write down the formulas. So the sum of the interiors is equal to n minus 2 times 180, where n is your number of sides. Now, here we have a shape that has 1, 2, 3, 4, 5 sides. So it's a pentagon. So n equals 5. So we plug that in, we get 5 minus 2 times 180. 5 minus 2 is 3. 3 times 180 gives us 540 degrees. So the sum of the interior angles is 540 degrees. All right, we're going to do these 4 here together. So number 3, we have a shape, and we're going to look and see how many sides it has. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So n equals 12. We're looking for the interior angle sum. So the sum is equal to n minus 2 times 180. So we do n minus 2 is 12 minus 2 times 180. 12 minus 2 is 10. 10 times 180 is 1800. So our sum there is 1800. All right, number 5. Number 5 says a regular 17 gone. Now, anytime you see 17 gone or 25 gone or anything like that, that is your number of sides. So this is what's called an n gone, and n in this case would be 17. And then you just do it like you would normally. So you do your sum equals n minus 2 times 180. So 17 minus 2 times 180, which is 15 times 180. And if we pull up our calculator here, we get 15 times 180 is 2700. So our sum is 2700 for a 17 gone. All right. And you should have a relative grasp on this. Just find the number of sides. You're looking for the sum, so you're going to take your n minus 2 times 180 and then plug in as you go. Just don't forget to subtract 2 first and then times 180. So you can try numbers 2, 4, 6, 7, and 8 on your own and check it with a key. That's posted with this video on the Google Classroom page. So let's look at the next set of examples. So we're going to do 9 and 10 together. So we want to find the measure of one interior angle in each regular polygon. So one interior angle. So it's similar to what we did up here with the sum, but this time we just want one. So we need to find the sum first and then divide it by the number of sides. So in our first one here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides. That's our n value. So our sum is n minus 2 times 180. So we get 12 minus 2 times 180. And if you work that out, you get the 1800. We worked it out in number 3 earlier. Now, you want to determine the sum, or the one interior angle. So you have to take your sum and divide it by n. So you take 1800 and divide it by 12. And when you do that, you end up getting 150 degrees. And number 10, try number 10 on your own, pause the video, come back. So number 10, you have a figure with 1, 2, 3, 4, 5, 6 sides. So n equals 6. So to find your sum, you do n minus 2 times 180. So you get 6 minus 2 times 180, 4 times 180, which is 720. But you're not looking for the sum, you're looking for one interior angle. So your one interior angle is going to be equal to the sum over n, which is going to be 720 over 6. And when you plug that in, you get 120. And of course, the next few problems you can try on your own, numbers 11 through 14. We're going to do numbers 15 and 16 together, and then you can work on the other ones if you would like, or you can go ahead and move on to the worksheet that's on the Google Classroom page. So find the measure of one exterior angle in each regular polygon. So this time we want one exterior angle. And in order to find an exterior angle, what we need to do is we take the sum divided by n, because we're looking for one angle. But the sum of the exterior angles is always 360. So what we do is we take 360 degrees and divide it by n. So in number 15, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So our exterior angle is equal to 360 degrees divided by 10. So our exterior angle is 36 degrees. Now, you could find your interior angle from the exterior angle and vice versa by subtracting it from 180. And we'll be doing more with that in the next example problems that we'll go over during the next lesson. All right, so number 16, I want you to try that. You may get a decimal, just round it to the nearest tenth if you do. So let's look at number 16. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sides. So we have 11 sides. We want to determine one exterior angle. So we do 360 divided by n. In this case, would be 360 divided by 11. And when you type that in the calculator, 360 divided by 11, you get 32.72 repeating. So it wants us to round to the nearest tenth. So we get 32.7 degrees. All right. And that's going to do it for this instructional video, guys. Again, I will have the key posted that has all the answers to the other ones. So please make sure you're on the lookout for that if you did do these, or you just want to look over it just to, refresh and familiarize yourself with those. Make sure that you are working on your assignments, and I hope this video helped, guys. And if it did, or if it didn't, make sure to email me and let me know so that I can best help you out. We can meet one-on-one and talk about this. So thanks, guys. I will see you in the next video.